let's consider the case for parallel vectors. Now, with parallel vectors, the thing we learned before was that if we were using u dot v is equal to the magnitude of u times the magnitude of v times cosine of the angle between them, if the vectors were parallel and in the same direction, the angle between them would be 0 degrees. So I put a 0 degrees in there, and we know from our unit circle work, cosine of 0 is 1. So that would imply that if vectors are in the same direction and they're parallel, then u dot v will equal to the magnitude of u times the magnitude of v. And then we said, well, what if they're in opposite directions? Remember, the great thing about vectors is I can click and drag them around. So if I have a vector here and a vector here, I can click and put their tails both at the origin in standard position. And if this is u and this is v and the angle between them is 180 degrees, cosine of 180, if you go back to your unit circle work, is -1. So when the vectors are parallel but in opposite directions, cosine of 180 is -1, and we'll get the opposite here. So that was our test case for vectors are parallel and in opposite directions. Now that's a lot of work. Another thing we can do is simply look for the common factor. I know that if I have v is equal to w, and I can come up with some constant k, a scalar multiplier, then the vectors will be parallel. How can I do that? Well, it's very simple. Just take x component divided by x component. 2 divided by 4 is 1/2, almost like you're playing a slot machine in Las Vegas. If it comes up 1/2, 1/2, 1/2, then the vectors are parallel. 4 divided by 8 is 1/2, I'm feeling lucky, and 1/2 is also 1/2. So that is our constant. Notice vector v is much bigger than vector w. Vector v equals vector w. What a ridiculous statement. They're not equal. Vector v is much bigger than vector w. To make them equal, I can say half of vector v is equal to vector w, or I can multiply both sides by 2 and come out with this. Now I've agreed with this form here. If I can find a constant or a scalar multiplier, if I can find out that the vectors are scalar multipliers of each other, how do I do that? Well, component divided by component, component divided by component, component divided by component. If they give you the same number 3 times, then the vectors are parallel. A much easier test than the one we had learned before.